All right, so here's the continuation, and just so you see, this is lesson 5.3 graphing, and so finishing off the lesson. So hopefully you're in the right place, and here's the rest of this lesson. All right, we stopped at number 3, and so this situation was unique. There's no domain listed, meaning that the domain is all the real numbers. What do? You choose values of the domain. All right, so I told you this is going to be a line, so we're going to choose 3 values. 0 is always a great one. I'm going to use 1 next, nice and handy. Again, I'm going to take the function, and where the independent variable is, I'm going to put a 1 in. So -1 plus 2 is a 1, so we have a 0.11. I'm going to come and graph that. Now, why do we do 3 points instead of 2? All right, whenever you have just 2 points, there is always a line that goes between them. However, if I would have made a mistake on the first point or a mistake on the second point, the line will be in the wrong place. By doing a third point, I'm cutting down my probability of error because all 3 points should line up and be in a line. So I'm going to use 2 for my third domain. So again, I'm setting up, putting 2 in for the independent variable. Now I have -2 plus 2, and my dependent, my y, is a 0. So now I plot 2, 0, and if everything's right, these will all be in a line, and sure enough, they are. Now, you need to connect the points with the line, and you need to put arrows on both ends. So you got to connect it, the points with the line, and put arrows on both ends, meaning the line goes forever to the left, forever to the right. All right, if you look at that line, does it pass the vertical line test? Is this a function or just a relation? In other words, can you find a vertical line that hits the red line in more than one point? And the answer is you cannot, so it is a function. All right, so this is a function. What's the domain? Well, remember, we set up here, the domain is all the real numbers. And here's what you're looking at. Don't the x values go forever to the left, and don't they go forever to the right? They do. And so our x values go forever left and forever right. No matter what x number you pick to the left, the line will be above it. No matter what number you pick to the right, the line will either be above or below it. So it's all the real numbers. Now for the range, what's the highest? Let me do lowest first. All right, I don't want to mess you guys up. Always like to go lowest first. If I go down to -10, is the line going to be across from it? And the answer is yes. If I go down to -50, is the line across from it? Yes. If I go down to -1,000,000, is the line across from it? Yes. So all the possible negative values. Now, how about if I just start going up? If I go up to 10, is the line across from it? Yes. 100, yes. 1,000,000, yes. A zillion, yes. So this line goes forever up and forever down. Therefore, the range is also all the real numbers. Okay? Domain, all the real numbers. Range, all the real numbers. All right, let's take a look at the next example. So in this one, we have a similar scenario. The only difference is, instead of saying xy, they said x f of x. So the only reason I have that there is to remind you that, remember, f of x can always be replaced with y, right? Now, there's no domain listed, so again, we're going to choose the domain. 0 is always a very good choice. So you can keep f of x. If you want to do functional notation, it would look like this. Now, don't get all caught up on this. Not a big deal. Your 0, I'm finding f of 0, meaning I'll put 0 in for the x. 4 times 0 is 0. 0 minus 3 is a -3. So I can do it in functional notation way if I want to, or I can do it in regular notation, and I'll do the second one that way. All right, so again, domain, you're picking, right? And look, you can pick 10 if you want, but then you need a bigger Cartesian plane. You can pick -40 if you want, but then you need a big Cartesian plane. So if you keep your numbers simple, it'll make life simple. So let me plot this point. 0, -3 is right there. 0, -3 is right there. All right, let's see what happens with 1. Well, this time I'll use y instead of f of x. Again, I still have 4. Put parentheses where the x goes, minus 3, and now I'm sticking 1 in. Okay, 4 times 1 is 4. 4 minus 3 is 1, and I have the point 1, 1. Okay, sounds good. I'm going to plot the point 1, 1. Now I might as well just keep going, because again, hopefully those are correct, and it's going to be in a straight line. I'll do 2. So y equals 4 times the independent variable. So again, what are you putting in for your independent variable? 2, right? And guys, remember, you're watching on video. Pause anytime you need to think about what's being said and absorb it. So again, doing the math, right? 4 times 2 is 8. 8 minus 3 is a 5, and we get the 0.25. Grab my green. I'll go 2 to the right and 5 up. And it's right there. Okay, again, remember, connect your points with a line. Put arrows on both ends. Connect your points with a line, arrows on both ends. Is this a function, yes or no? Yes, it is a function. So you can write yes or function. Okay, does the line go forever to the left? Yes. It's going down steeper, but it has forever to go left. Does the line go forever right? Yes. What's the domain? All the real numbers. Does the line go forever down? I'm doing the range now, right? Range is down and up. The domain is left and right. Does it go forever down? Yes. Does the line go forever up? Yes. What's the range? All the real numbers. Okay? So again, we chose whatever points we wanted to for the domain. And again, I want to keep my values down. That'll keep my graph from having to be too big. All right, we got one more. This one's a little unique. On this one, give the domain and range. So there's nothing to graph here. We need to state the domain and we need to state the range. All right. Now this one's unique. So again, whenever you're thinking domain, domains are left, left and right, right? Domains are left and right. So whenever you figure out your domain, you have to figure out the lowest value to the left. Is the -1 part of the domain? And the answer is no, because of that open circle, right? How about -0.99? Is that part of the domain? Yes. How about -0.5? Is that part of the domain? Yes. How about 0? Is that part of the domain? Yes. In other words, do I hit the line from it? Do I hit the line from a half? Yes. Do I hit the line from 1? Yes. Do I hit the line from 1.5? Yes. Do I hit the line from 2? Yes, right? Do I hit the line from 2.1? Yes. 2.2? Yes. 2.5? Yes. 3? Yes, right? 3.1? No. So let me show you the domain. Let me get rid of all this extra stuff. So here's how the domain would look on the x-axis. The line, the blue line, the blue segment is just bigger than -1 all the way up to and equal to 3. Now think about conjunctions. How would you draw that red conjunction? You would say -1 less than, and by the way, are domains x's or y's? They're x's, right? This is the x-axis. So -1 less than x, less than or equal to 3. That's our domain. Okay? Now the range are the y values. And again, you should always start at the lowest value. Well, what's the lowest value where the function is across from it? Well, just bigger than -2. Again, I have to use an open circle because that's an open circle, right? When I go left, I hit an open circle. But if I went to -1.5, I would hit it, right? So that's part of it. -1's part of it, etc. Like I did before. All the way up, what's the biggest value? And hopefully you're thinking the biggest value is 2. And again, 2 is included because it's a dot, right? If I go to the right, again, I'm looking up and down. How high does this thing go up and down? And now, again, I just connect it. So how do we say values just bigger than -2, right? Just bigger than -2, all the way up to including 2? Well, it's kind of the idea that we did with the domain. -2 is less than, but listen, are the ranges the x's or the y's? They're the y's, so a y goes there. Do you know how to finish it? So we're from -2, and then hopefully you said less than or equal to 2. That means any value just bigger than -2 all the way up to and including 2. All right, that's the lesson, and that's how it closes out. Um, I will not quiz you tomorrow, so I did make a change, and the quiz will come on Thursday. Everybody will take the quiz on Thursday. All right. And I did make a change of our schedule for the rest of the week. So if you happen to copy down the schedule in the beginning of the week, I did make a change, and that change you should be able to see that when you go on to InfoDirect. Make sure by Thursday you would have read pages 200 through 203. All right. So by Thursday, read those pages. And that's it. See you in class.